So today we are back to ZIO, and in particular, let me actually just get rid of some of the stuff so we can do it ourselves. Just make this. Okay. So in particular today, we're going to focus on a new feature that got added, or maybe I should say expanded on in ZIO 2.0.17 to make it easier to build your dependencies with ZLayer. And overall, I think probably most of you who are using ZIO have seen, I think ZIO is relatively mature. So I think a lot of things we're doing right now are kind of just like making things a little bit nicer for people. And I think this was definitely one that fits in that category. So one of the nice things is ZIO is binary compatible now. So all these things are not going to mess with anything you're already doing, but just kind of give you other ways to do things or address pain points you might be having. And all this is like totally opt-in, right? You can use this in your code or you cannot. But what I think I'm going to do here is I'll go through kind of a simple example of building some services with ZLayer. And then we'll look at this, this new functionality and how that can maybe make it a little bit easier for us. And as we go through here, feel free to jump in with questions. I'm just going to make sure I've got my iPad here with the Discord, just so I can look at that while without switching screens here. And I feel like using layers and building your dependencies, I think it's got a lot easier. But I think it's still something that people have questions about. So as we're going through, if anyone has questions about anything, feel free that's related to this, or I guess more broadly, feel free to ask it, and I'll try to cover that. Cool. And hi, Naveed. Yeah. Okay. So I'm going to start off by just creating some basic services. And so I think a pretty straightforward pattern might be I have some, like, let's call this trait service A, right? And it has some method that's going to do something. And yeah, maybe this is database, maybe this is something else. Right now, at least initially, we'll kind of have all these just be kind of abstract concepts of services. And then let's imagine we have a couple other services. And so we're following the first part. So if we think about kind of our usual pattern for building services, we could say it's kind of got three parts. Maybe as we go, I'll end up adding a fourth. But first we could say we define our service interfaces, right? So that's what we've done here. Then what we would normally do is define concrete implementations of those services, right? And that would typically be as case classes. Then 3, we would define layers that build those services. And then 4, we would wire everything up. And I guess, in the little like internet meme thing, profit. Okay. So we've basically done step 1 here of we've defined these different services. And then the second step we'll have is we'll define a concrete implementation of those services. And a typical way we'll want to do that is we'll create a case class. And it doesn't have to be this name, but a very common pattern would be to call this like service A live or maybe if it's not just live, but it has something else that makes it special. It's the Redis implementation of the service, or it's the Postgres implementation of the service. Maybe it's service 8 Postgres. But it would basically be a case class. And then any dependencies that this service needs are going to be reflected as parameters of the case class. So for this example here, we'll just start with having a very simple topology, and we'll say A depends on B and C. So maybe in this, like A is like a repo, and maybe B is database, and maybe C is some kind of like monitoring service. And so we would just put each of those things as dependency here. So we would say, okay, the service A live depends on service B. That's a service B. And service C, that's a service C. And then I often forget to do this, but then we extend the interface, right? And then we implement the interface. So maybe right now I'm just going to be very simple, and I'm just going to call this hello from service A live. And right now I haven't given myself anything to really do here. Maybe make this slightly more interesting. I'll make this string int, and then maybe I'll do for yeah. So then I could say something for like string service B and int and service C. Then I can print out service A live. String. Yeah, let's make that a little bit nicer. Some interpolation here. I'll just get some auto compilation going, help myself. Okay, so we're doing the step here of we're defining these concrete implementations, and we're just taking each of these as constructor parameters. And so this part here really mirrors just very traditional, like if you're coming from Java, constructor-based dependency injection, right? We have this service A depends on services B and C, so we don't do anything fancy here. We just take these as constructor parameters. And we can basically do the same thing down here. And maybe before I do that, let me just highlight one other thing, which is sometimes you'll have a question about where to put this. Sometimes you can just put it as a top level thing. A lot of times, actually, this may even belong in a separate project than the implementation. So you can imagine that if like this is a database or something, maybe service B is a database, this just definition of the interface might be in a common package. But then you might have different packages that different dependencies that implement that interface in different ways, right? That one depends on Redis and one depends on some completely other persistent solution. So these don't have to be in the same file. They may be in completely different projects. If they are in the same file, you'll also, I think sometimes something that I like to do is I like to put them in the companion object of the service if they are going to end up being in the same file, if they don't have those different dependencies like that. So I might do something like this, and then I might even make this private because I want to kind of treat this like service A live as like an implementation detail that like isn't part of my API that people don't get to rely on, and they only get to use the layers that I provide to them. But that's all a matter of preference. And so I'm going to do the same thing just quickly here. And I'm going to make these pretty simple right now. And so here I'll just do like And one of the things you'll notice here is that even though these don't actually take any dependencies, these are kind of the roots of my dependency graph, or the leaves of them, I guess, depending on how you conceptualize where you start and where you end. We still use this case class here. And that's just for consistency of basically my recommendation to people is usually essentially always use a case class or a trait. If it's data, it's a case class. If it's an interface, it's a trait. There's never anything else. You never need to worry about kind of the class or the sealed abstract class or like all these other things. Just use those two things. There are more complicated cases where you end up needing them, but I'd like to say like don't think about that until you really prove to yourself that you need that. So I think this just keeps things nice and simple here. So now we've done this step 2. We've defined these concrete implementations. And then step 3 is we're going to create layers that build those. And so the traditional way that we would do that is I'm just going to find the Z layer. And so this is going to need a service B and a service C. Let's say right now it can't fail. It's going to return a service A. And we would do something like we'd first use this Z layer constructor, and then we use a for comprehension. And we basically grab each of the services. That's not right, that's remembering. But we're just going to grab each of these services. And then we're going to construct our implementation. And I personally like this a lot because it's just very flexible. Where here, I'm just doing the most basic thing. I'm just grabbing these services. I'm just putting them in here. But it gives me a lot of ability to do anything else that I need to do. So let's say there's some type of initialization that I need to do here. So then I can do service. Or let's say there's some kind of finalization I need to do. I could do ZIO.add finalizer shutting down service. Or let's say one of these things needed to have and then if I have this finalizer there, then all I do is I just change that to ZLayer.scope, and that's going to work there. So this I think is nice because it's like super flexible this way that you can really do anything you need either with just the Z layer or the ZLayer.scope. This is kind of going to take care of you. And so it scales with you really well to go from building simple things to building things that have a lot more complexity here. Right now, let's kind of stick with a simple one. And so we'll do the same thing right now. And so we'll do the same thing down here. So I can do val live. And this one's really easy. I can kind of the third way is if I don't even need any dependencies, I can just do this ZLayer.succeed. And I can do the same thing here. And let's confirm it's working for me. Yeah. Actually, I don't really love these kind of type aliases for ZLayer. I think it makes things a little bit less readable, so I'm just going to replace that. But that's just a personal preference. And let's see, here. Oh, so this is my mistake, and actually with both of these. So I probably don't want to expose the service B live. I just want to expose the service B, or in this case, service C. And so there, the compiler is kind of helping me out. And this is doing what at least I'd like to do, which is I'd like to say, hey, I mean, imagine I'm working with other teams. I'm saying you get to rely on the service B interface, and you get to rely on this do something else method. But you don't get to rely on anything about this service B live, because the service B live maybe has right? Maybe I do some helper method before this thing. And I don't want to get in a situation where my internal clients who are using the service B thing end up like relying on the service B live and doing some crazy thing where they're like calling this helper method directly, and then they're relying on it. And then when I refactor this thing, I break their code and they're not happy with me. So that's kind of why I like to keep this private. And then you just always expose the interface here versus the concrete data type. And then the final thing would be if we want to actually use this. So let's say my whole application here, it's just a really simple application right now, is I just want to like run this do something thing. So then I could say ZIO.service service A. And then I could flat map that. And I could do something with it. And then I'm going to need to provide it with its dependencies. And so I've got this service A.manual. I think most folks have seen this before, but I'll just kind of show this again to people who haven't. There's this nice functionality here where if you don't provide all the dependencies you need, you'll actually get this nice error message that says what's missing. So if I don't provide anything, then I'm going to get an error message that said like, hey, you said you want to use a service A, but you haven't given me a service A. So, okay, I'll give you a service A. Well, great, but your service A requires a service B and a service C. So let's just give it like the service B. Okay, I'm still missing, I appreciate the service B, but I'm still missing the service C. Let's add the service C. And now this program is ready to go. Let's run it. And so if I copy this up here, we see we ran the helper method that we had in service B, I think. Yep. And then we said hello from service live. We had hello in 42. So that's kind of the way we've done things up to this point. And I mean, I'm sure everything is, nothing is perfect. Everything can be improved on, but I think that's like pretty good. I think it gives us a nice way, right? We want to separate our interface from implementations. This gives us basically just traditional constructor-based dependency injection. This gives us the ability to do acquisition and finalization of resources in like a sane way, where it's not just like when the like class is like deallocated or something. And then this wiring is just super easy and has these nice error messages. So I think that's a pretty nice flow. But I think if we were going to be like a little bit more like critical or like how can we improve it, I think people have felt like, especially when you have simple services like this, that there's a little bit of boilerplate here, right? Of like, especially, I mean, here there are like 2 services, but imagine that I have a bunch of other things here. And imagine that I don't just have these 3 interfaces, but I mean, in production code bases I see with ZIO, you might have like 100 different services that you're ultimately wiring together. This, I think people said like, hey, like, is there a simpler way to do this? Because here we can kind of just see a pattern here of like, we've got the case class that has its dependencies. And all we want to do is we just want to create like a layer here that basically moves each dependency into here, and then just takes the actual service and puts it here. And so we had a couple of ways to do that in the past, but I would say they were all kind of really only worked for like the most simple case. So like this one here, if I wanted to, I could do this ZLayer dot from function thing. And then I could do service A live. And that works too. And this is basically based on treating this case class's apply method as a function, right? So we can think of the case class as having an apply method, that every case class automatically gets created with an apply method. And it's a function. In this case, it's a function 2. that goes from a service B and a service C to a service A. And I think we can actually even see that, or we could do like something like val function is equal to service A live dot y. I'm going to do this little bit weird underscore thing. Okay, well, this is just, again, the private thing. Let's make this private, not privateer. That's a different thing. It's kind of like pirate. Okay, and so we see that, right? That the service A live apply is just this function too. So that kind of works for these simple cases. But what I think people ran into when using that is if you want to do something that's any more complicated than this, then this kind of doesn't work for you anymore. So let me just revert that for a sec, just so we have the I know. It's true, Naveed. So let's say that we also want this to have like a counter that's a ref event. And let's say we also want to get like times is going to be counter.update and get 1. And then we might say something like this is invocation number 1, right? And so then maybe just to make this easier to play with, I'm also going to create a little, what we call the accessor method here. And that'll just let me slightly simplify this to, maybe I'll split this out. So I'll say like val my program logic. And maybe we'll start by doing and then this can just be my program logic. That I find it sometimes like a nice pattern. I mean, you don't have to call it this, but just this way you kind of separate out what your program is doing, and then your main thing is just providing that. So let's see, did I get everything? No. Okay, so right. So here we have this counter that we want to be a ref here. And I think that probably this is obviously a little bit of a contrived case here, but I think the situation of wanting to allocate some state for the service is actually a really common one. And so you can see if we go back to, let me comment this out, and let me try to do our ZLayer dot from function here. And then I can do service A live dot apply. So we got kind of a not particularly helpful error message, but the underlying problem here, and I mean, it can be a problem or it can be not a problem, but I think it's kind of a problem, is that this ZLayer from function thing is not, and I mean, kind of can't be very smart. Like all it does is it looks at this apply method as a function, and it just translates all the parameters of the function to the input types of the layer. So it says, okay, well, and let's even go back and do my little private val func equals service A live dot apply. And right, it's now instead of a function 2, it's a function 3 because it takes you 3 things. And one of them is a ref event. And so what it's basically doing is pushing this ref event into one of the dependencies of this layer. But that's not really what we want. Like if we were doing it in kind of the old-fashioned way, so to speak, what we would do is, and this is again where kind of having the for comprehension is nice, we would do like ref.make, maybe I'm going to start this off with being 0, And then I would just put the ref in here. And then I can delete this from here. And now my code works. And you see we called it twice, and we had this shared state, and we maintained that state. So that's where like this is nice, but the just like from function, kind of what we had before, didn't scale for this. And we can imagine other situations of essentially if this was like a queue or a hub or anything else that kind of we did need to create as part of this, but we didn't want it to be another dependency that got exposed to type of our layer. We just wanted it to kind of be done in the body of building the layer, which is really what we're doing here and where this has some meaning. We didn't have a easy way to do that. And also this thing was the from function thing is like quite specific to like it has to be a case class. It has to have these parameters. The case class obviously has its own restriction of like it doesn't have curried parameters and so on and so forth. So what a ZIO user and contributor by the name, and I'm totally going to butcher this, but Grissom, I believe, did was he worked on some really nice macro-based functionality for this. And he's actually been kind of on a roll with macro-related things to make it easier to work with ZIO, because you may remember he also did the stuff on the easier way to create reloadable services that was also macro-based. So he's been doing a lot of cool macro stuff with kind of just like trying to make things easier and tackling how to do it on Scala 2 and Scala 3. So definitely props to him for that. But so what he's worked on is this thing that's called ZLayer.derive. And so I think I'll start by just taking out the counter thing, just so we can see it kind of works the same stuff. And then we can add the counter back in. So ZLayer.derive expects you to give it a type, which is basically the class that you're constructing a layer from. So in this case, we're going to say ZLayer.derive service A live. And then we compile that. So that works totally fine. And we don't even need to do any kind of case class like apply. We just say the target type, in this case, right? The type is implementing the service. And as long as it actually implements the server's interface, then this is going to work for us. And because this is a macro, there gets to be like a lot more logic that gets built into this. And so it gets to be smarter, so to speak. So one thing I can do is, let me say for whatever reason, I don't want this to be a case class. I have whatever my reasons are. I don't like case classes. So well, my little function example is actually a great illustration. So my little function example isn't going to work anymore because service A live now doesn't have any apply method. The apply method gets automatically generated for case classes, but this is no longer a case class. And so if I did it the old way here, if I tried to do ZLayer.derive service A live apply, this is going to tell me that there's this doesn't work. But if I do this ZLayer.derive service A live, then this is totally fine. And it's also a little bit smarter that it can handle weird things I can do, like I think I can technically do this. Wouldn't really recommend this, I'm not sure, but if you really want to, it'll handle this. But where I think it gets a little bit more useful is when you have things that, again, you want to construct, but you don't want them to appear in the signature of your service. So let's now look at something like, let's say I put a promise in here. And maybe this is like await shutdown or something like that. And so we could imagine, I mean, let me just maybe try to make this like slightly more real. So we could have some kind of like shutdown. And then like the wait shutdown. And so we can imagine that shutdown is going to do something like ZIO.debug shutting down. And then it's going to sleep for like a second. And then it's going to complete this promise. And so then if we want to await shutdown, we can just await the promise here. So this is another example of those things like that ref we looked at earlier when we were doing the counter, that if we did it kind of the old way, I did the Z layer, and let me make this a case class again. So I'll do ZLayer dot from function service a live dot apply. This is going to have that promise in the type signature, which I don't really want. Let me just do these. So I'm just going to ignore that. And I think I called this, maybe I'll call this like shutdown latch. Maybe just call it promise. That's what I do. Yeah, promise. Okay. And right. And so now, because we had our like simple thing propagated that promise up, which we didn't really want, now we're like having to provide this up here, and we have this random promise floating around our dependencies, and maybe it's not going to the right place. So that's not a good situation. We want to get the promise out of here, and we want it to be constructed inside the body of here, like we were doing before. And again, if we had the kind of old, if we were doing it manually, that would be pretty easy to do, because we would just make the promise and we would stuff the promise in here. But we don't want to have to do that. We want to try to make things a little bit simpler for ourselves. So let's see what happens when we do ZLayer.derive service A live. So here, it just works. And notice how this type checks. So when we ask it to derive a service from service A live, it's smart enough to know that certain things shouldn't actually be propagated out as dependencies of the service. And basically what it's going to do is it's going to look for certain ZIO data types. So essentially there's like a set of like standard ZIO data types, like promises, queues, hubs, refs, that if possible, it's going to try to construct directly for you, so you can keep using this derive longer, and you don't have to kind of fall back to doing the manual layer construction. And realistically, there are probably going to be cases where you're going to want to use the manual anyway. So I would think this is not necessarily always replacing constructing layers yourself, but more just expanding the boundaries of kind of what counts as simple that you can do yourself. I see Tobias has typing a question here. Yeah, so Tobias is getting to a great question of what's the default, and that is indeed the thing that comes up with some things, and so there are a couple of aspects of like the default. There's kind of what's the value, you could say, and what's the type. So one thing we actually don't have to worry about is the type thing. So you can see here, like I made this a promise of nothing unit, and this was totally able to derive a promise of nothing unit. And let me say this is a promise of throwable unit, say. Well, this I'll have to ignore so that this works. And And oh, right, and then I would need to update my manual example. And you can see that works fine too. So in terms of types, it's actually kind of an easy problem of the type is whatever you said it is, right? If you, in your constructor-based dependency injection implementation here, if you said you needed a promise of throwable unit, then we'll make a promise of throwable unit. If you say you need a promise of nothing unit, we'll make a promise of nothing unit. If you say you need a queue of Booleans, we'll make a queue of Booleans. Let me kind of keep going on your question, because I think you're going in a great direction and actually exactly where I wanted to go as well. So high level idea here is we could say like generate the layer from the implementation of it. And so we said one thing we're going to do is we're going to generate ourselves values for common ZIO data types. And I think the ones it works on right now are like ref, queue, hub, and promise. And so that kind of creates a subsidiary question of what defaults for those values. And you kind of have a couple of subsidiary questions under that. So I think the first one that we addressed is what types? And the answer is basically whatever you say, right? The types in the implementation are what is created. So that's kind of the easy one. Another one, yeah, so Alexi's asking for custom types. So you guys are like, you're my plants. You're going in exactly the direction that I'm going, but I'm building up to that. So yeah, so we're going to get to that in a second. And then there is one question about any plants that have the same thing with annotation with Scala 3. So this already is Scala 3. So everything I'm doing is Scala 3. There are a bunch of issues with annotation macros in Scala 3. So I don't know, maybe, but I kind of think you already probably get more than the value out of this, especially because the annotation would just have to have some arbitrary name. So like, I don't really think you're getting any value of an annotation versus this. But you know, if someone wants to add something, we can look at it. Okay, so let me come back to this defaults question. So one question is kind of what types. Another like related to that could be like what I don't know, I'll call it settings for those types. And so for some of these, it's pretty easy of like, when you make a promise, you just make a promise, right? That's exactly what we saw here. So for a promise, I don't have to, there's no other question. Like there's only one way to make a promise. So that's super easy. Let's look at a couple of other of these though to think about this. So another thing we might make is a queue. And we immediately see that we have like different values of a queue. So when we have to pick one, right, it has to either be bounded or unbounded or so on. And so for promise, we can say only one way to make a promise. For a queue, the default is unbounded queue. For all these, we'll see how to customize later. Similarly, for a hub, the default is an unbounded hub. And then the other one that kind of interesting is this ref. And the ref is interesting because when we make a ref, we've got to make it with some kind of starting value, right? I mean, sometimes it may be simple, right? The value may be just like 0 when we did our counter, but it could also be something more complex. It could be your own user data type that has some particular starting value, right? It might be some state that you're maintaining some kind of state machine and you defined a particular state for what you're doing here. So that's where this concept of a default value comes in. And so what you have the ability to do is you can specify the default value you want to use for different types. And so let's look at this. So let's say we want to go back to more of our original example. So let's, I mean, we can leave the promise here, but we'll, in addition to the promise, we'll have the ref that's initially going to be a ref of int. And so we'll do this. I guess we'll call this counter, just this code works. And then we'll bring that back. Okay, so now we have a ref here. And so now here, we'll just, in this version, we'll just put the ref in here. And so right now, it's passing that ref through to these dependencies because it kind of doesn't know how to build the ref because it doesn't know what value to use for this integer here. So let's look at how we can address that and see if I can remember these. So we could say val default int is equal to ZLayer.derive default. And then I'm just going to want to succeed with a value. I'm going to call this 0. And the only thing that's a little bit tricky here is just for the types to pick this up the right way. I want to use this type here that's got this additional information. And basically what this is capturing is how this thing, how constructing this default value can fail and what other services constructing this default value requires. And then I'm just going to make this available implicitly here. And now my code is going to compile. So this is basically me telling it how to make the value it needs. And as long as I tell it what the default value is for like the ref, then it'll start the ref with that default value. Now, maybe I don't feel great about just having a default int because this int is like this like random type. So maybe this is where, kind of to this point about user-defined data types, I want to create my own thing. So maybe I have final case class counter state. Value is going to be a long. And let's say, just to make it easier for me to, I'll say, no, I won't worry about that. I'll do that below. So then I can make this a ref of my counter state. And so then this is going to be times dot value. And then this is going to need to be that needs to be updated. And so now all I need to do is I need to change this to specify a default counter state. And maybe that's going to be counter state 0. Let's see if I got everything here. Oh, and then this one also needs to be updated the same way. So anytime I need to customize something, I can basically create this default value that says like, hey, here is the default value that I want to use for this thing. And I can kind of control how widely I want this default value to be available by where I put it. And it kind of follows the normal rules of Scala implicit. So before, when this was the default int, maybe it made sense to just have this really in line here because it just want a default value for integers just floating around. But now this is kind of specific for this counter state. Maybe it makes sense to pull this out. And if we follow our normal best practice about implicits, a really good place to put it would be in the, not there, but in the companion object of that thing. Let's see, I think we just have some, object counters. And there you go. And yeah, so you do want to keep that type information here. And I mean, one easy way you can do is you can also just not give it a type annotation. So I believe, now in Scala 3, it always wants you to have it. So I think, let's see, this is probably going to give me some really ugly thing if I insert that. Yeah, that's not the nicest. So I'll go back to what I had. But yeah, so if I pull this out, I don't think this is going to work here. So let me just demonstrate that for you. Maybe it'll work. Yeah, so that is not going to work. So yeah, you do want to hold on to that, but just use that with context thing. Maybe we create some type alias to like make that simpler in like the common case where these don't have any dependencies. But the idea here is that you're let's say we wanted our, like the state that went in our ref required some allocation itself. So let's say instead of this, let's say for some reason making the state required doing ZIO effects, right? So we could instead do either from ZIO or from layer. So let me do like from layer, and then let me do something like ZLayer dot scoped, and then for blank and ZIO.debug allocating other state. I don't even need to do that. I can do ZIO dot finalizer deallocating counter state, counter state 0. And this might even require something else. ZIO.debug. Right, maybe this needs like a network connection or something. So we need to be able to express that here. And then let me make sure I just got my, I'm actually using my automatic one. And so you can see, if you look at this, this did exactly what we want, right? Before, we needed the counter state as part of our constructing our service. And so before anything else, we construct the counter state and we deconstruct at the very end. So we're doing exactly the right things here, even though this is being done kind of automatically for us. Let me just check in questions here. Yeah, so Nabil has a question about config. And config basically works the same way. So I guess maybe when I list these types, I should also put in config that if you need a type and you have a config for it, then it'll grab it from the config. Let me see if I can do a example of that. So let's say we just add even more stuff to this. So let's say we also have a port number that we're supposed to be using. Oops. I have to make sure I remember to do this. So if I'm doing something manually, then I might do create some config for this. Okay, I guess let's see, what's remember my little, okay, so then I would do like port number dot config. Oh, default. Oh. No, did I do the same silly thing, right? Yeah, okay. That was silly of me. Object port number. Bring this up here. Get rid of these guys. Okay. And, let's call this default. Just call this. And then this will be port. And this will be port. No, and then this actually needs to take a port. And for a second, I'm just gonna comment out the auto one because we'll look at that in a second. And let me just replace this with the manual just so we can kind of look at what we're doing here the old-fashioned way first before we, and I'll just ignore any errors in loading the configuration. No, not that, but let's see, is the config error throwable? I think that's, yeah. Okay, so this is now going to blow up because I don't actually have a port number specified anywhere. But what this is doing is, and I don't think we've really done or we did one session on config, but maybe just to go back to kind of the basics on it. So ZIO has this concept of a config here. And this config, you could think of as like a declarative description of what you want loaded versus like where it's being loaded from. So this is like saying, hey, there's this thing called a port number, and it should be nested under something called port. And when you read it, you should read it as an int, and then you should take that int and you should put it into this port number case class. but it doesn't actually say like where you should look for that port thing, right? You should look for something with the word port that's nested under it in some conceptual way, but doesn't say whether that should be like a environment variable where port is the key, whether it should be a system property, whether it should be in some other YAML file. It could be any of those things, but just conceptually, it's something that is under a label of port that can be converted into an int and then will be put into a port number. And then when we do this ZIO.config thing here, we are using ZIO's default configuration provider. I think the default configuration provider, I think, looks first in system settings, then properties, or the other way around. Basically just looks in those two places. And it's going to look there. And obviously it's looking there and it's not finding it, which is why it's blowing up. But you could also use an operator called with config provider to specify whatever other config provider you wanted that would load from your Vulkan file or whatever you want. So just to show that for 1 sec, just before we go on here, you could have this whole thing, and then you could do with config provider. And then especially that's where if you want to do anything fancier than just like system properties environment, that library ZIO config provides config providers for all sorts of things you could want. And there's a previous Zymposium with Afzal where he goes through some of that if you want to check that out. But anyway, to get back to our thing, and then I'll probably wrap up here because we are getting to about an hour here. Our question is kind of, okay, how can we use the derive thing and not have to fall back to it even though now we've got this fancy port thing. And so I think all we're going to do here is I think if we make this implicit, oh, right. And so you see it did pick it up. The only thing that we had here is we had the fact that we have this config.error that we have to deal with. So I think I have, let's see, do I have like a map error? Yeah. So I have a map error. Let's see, I think I have an or die. Yeah. So I'm just gonna say I'm going to treat that as a fiber failure right now. And so now I can do things automatically, even though I'm doing the config. So we're kind of continue to push out the boundaries of what we can do without having to use the manual layer construction. Even though if you like the manual layer construction, you can still do it. I tend to do the manual myself, but I'm also probably old school that way. Okay, let me show you. Well, first, if anyone has questions, like type them in so we can cover those. But otherwise, I do want to just show you one other thing before we wrap it up here. And so I think we've seen here now how, in terms of just having values that are in the that are required by the implementation that you don't want to pass through as dependencies, I think we've got a pretty good set of solutions for that. We've got a couple of kind of off-the-shelf ones, like we saw with the promise, but then this with default thing really gives you a lot of power to specify where something comes from. And then the config, I think, is another kind of nice example of like just making common things easier, and you don't even have to specify, well, the default comes from one of this config. It just kind of happens for you. So the final thing I want to show you is acquisition and finalization. So let's go back to our example where this, so let's start with our manual implementation. And let's say that we had to do something to acquire this service, or we had to start some process. So like, let's say this is like starting background health check. And then when we're done here, we need to I don't think they actually will do the promise don't succeed, but you want to shut that thing down. And so in the manual way, that's pretty easy, right? We just do that. We just can do any effects we want to acquire things. We can add finalizers for any finalizers we need. We just change the ZLayer to ZLayer.scoped. I think I am going to just blow away this port number thing just so I can actually run this example here. Let's see if I have something. No, I'll take the port out of here. And then this just says, doesn't make sense for me to die it because it can't fail anymore. You'll notice one nice thing here about this derivation is it's in a way very flexible where when I changed my case class here, I had to change my manual implementation, obviously, because like it doesn't expect the port anymore. But this derivation just still works because as long as it can find the things that you're asking for, it's happy. So let me run this with the manual one. And so we can see it did kind of what we wanted to do, right? Of it started the background check at the beginning, and then it stopped the background check process or the background health check process at the end. So our question could be, how do we recapture that with this derivation stuff? And yeah, I see a couple of folks join late. There's definitely going to be this definitely being recorded. I think we've got it set up now, so it automatically starts recording at the beginning, so I can't forget to record it. And yeah, I think we've been better about getting these videos out, so I would think it'll be there by Monday, I would think. Anyway, and I'll also point to the links to the documentation about this, because you can also check that out. Okay, so let's see how we can do that here. And so the way we can do that is when we implement our service live, we can extend one more thing, which is this ZLayer.derive is all in this derive namespace. And then I'm going to extend this acquire release thing. And I think this needs some type parameters, I believe, which is basically, yeah. So this is basically what environment the acquire release is going to use, how the acquire could fail, and then any acquired state that's going to be acquired in the acquire and available in the release. So right now I'm going to say I don't need any state, so I'll just call that unit say, or maybe I'll call that any. Okay, and if we look at this acquire release trade, it's a pretty straightforward trade. It basically just has two methods that, surprise, surprise, they're called acquire and release. And they have, I think, very normal signatures that we would expect, right? The acquire kind of returns something, the release releases that thing. So here, I could implement those. So I could do def acquire. And yeah, I do have them. That was really working for me today. Def release. And so I can basically just have the same logic that I had down here. So this will be starting the background health check. This will be ending it. Don't need a second equals. Oops. Oh, and now this doesn't need to be add finalizer. This is just the thing. Okay. And so now let me try running. I'm going to substitute this in with the auto. And you can see it started the background health check, and then it shut that down at the end. So there's both that ZLayer or ZLayer.derive acquire release. And then there's also, I would say that maybe is the easier one. There's also one called scoped. Yeah, there's also one called scoped here that if you have a scoped value already, so maybe like, let's say, here, sorry, I forgot to make this bigger for folks. Hopefully everyone's got the big screens. But so let's say instead, I wanted to make this scoped. And then I could just define one thing. And maybe here I'm going to use some scope value. So maybe I'll do ZIO.debug checking health. I want to do it every 10 seconds. I want to do it forever. And I want to fork a scoped fiber to do that. It's going to kind of go as long as I'm going, and I'm just going to stop. And maybe just to illustrate this, I'll make this 1 second. And then after I do my two things in my main program, I'll sleep for 5 seconds. So let's try running this. Let's see what I got going here. Oh, I just got the signature wrong. This should have a scope. Okay, and then oh, I just need a trace. That's easy to solve. Okay, so we see the health check is running, and then health check stops. So I think this can be nice because, again, I think like a lot of people have the intuition that you basically want to encompass all the logic in your class, right? And so people like being able to like kind of define the acquire and the release or the scoped. And you can definitely like, let me show you just how to do it the other way. So let's go back to when we had the separate acquire release here for a second. So if you wanted to, you could also, now that we've defined these acquire and release things as part of this interface, we could instead do something like, let me do service A equals service A live of all this stuff. And then I could down here do like service A dot acquire and add finalizer service A dot release. And then I could just yield service A. Just make sure that compiles. Oops. Oh, and then I just need to, I just need my same little just trace thing. Oh, and then I need to extend acquire release. I think that's what happens. Oh, and I don't have traces here. And so it's kind of expressing the same thing, but I think people just like that, or I think people will like that you can just define it here and you don't need to kind of then have the logic here to put it into these two. And acquire, release, and scoped. Acquire, release is just a more specific version of scoped. So if you kind of need the more general thing, you can just use scoped, and then anytime you have an acquire release, you can just do ZIO.scope or ZIO.acquire release, acquire release. So like scoped is like the most general version, and then acquire release is like kind of a more specific subtype of the scope that just gives you an interface that can be slightly easier. So I think that's what I've got for you. We're at a little bit over time, so I think this has been a good session. But maybe I'll give 1 minute for if anyone else has questions or stuff they'd like to cover. I mean, definitely folks can keep adding to it. Person definitely, I think, took on a lot here, and overall did a great job on this. Though, I think as with everything, there's opportunities to improve. So, Nabil or other folks, if you want to kind of the stuff you want to add to, you can definitely take a look at that. I'll give maybe just a couple more minutes for anyone to jump in. But then, yeah, we can call it a weekend here. Config derived macros. My general bias is I feel like we already have a lot of stuff in ZIO core, so I tend to be biased towards kind of keeping it about where it is. I mean, I think it's good that it's like batteries included, but there's also kind of a point of like it's good that different libraries get to be built and kind of focus on their specific domains. But yeah, it's kind of always a design trade-off to think about. All right, cool. Well, thanks so much, everyone, and have a wonderful weekend.